Welcome to this final session in the Xpert Theater here at GreenTech Live and Online. Great that you're joining. Maybe you're joining again after the sessions of this afternoon and morning. Yeah, we've got a really interesting topic for this last session. We're going to talk about automation and robotics. But before I'm going to introduce the speakers and tell more about this topic, first of all, let me know who is watching. Because, yeah, we're curious. We can't meet live with you now, so of course we're still curious, and I'm sure that the speakers are as well. Who's joining us today? So there is a button when you are in the area of GreenTech Online. There's a chat button. Please leave your name and the country you're watching from, so we have a bit an idea who's joining. In the meantime, I will tell more about the topic we're going to talk about today. Yeah, there's been a lot said about the autonomous greenhouse already, but this hour is again about this topic because how far are we ahead of a full autonomous production? And what kind of techniques do we need for that? What kind of data comes out of the greenhouse? And what can we do with all that data? We've got two experts here who can tell you everything about this. First of all, Erik Pekkeriet, hello, welcome. Wageningen University. You're a program manager at Agro-Food Robotics. And can you give me a bit more background?
Yeah, that's correct. At Wageningen University in Research, programmers are responsible for the portfolio of robotics in all domains, so also in the open fields, but also in greenhouse horticulture. So that's what I chose today, to talk a little bit more about robotics and where are we now? What is the state of the art? And why are we not full autonomous already? And that's also a question.
And do we get an answer to that question at the end of this?
Well, let's see.
Okay, I'm curious. Otherwise, I will definitely still ask it afterwards. But let's go to our other speaker. Thank you, Erik. Great you're here. But our other speaker of today is Guido de Croon. You're a professor at Delft University. Hi, Guido. Great you're joining.
Hi. Yeah, great to join.
Yeah.
So indeed, I'm. Sorry. Mm-hmm.
No, I actually wanted to say, what a beautiful drone you have behind you.
I think, indeed. Yeah. It's flying, it's buzzing around here.
Cool. So cool. You're probably going to talk about that, right?
Exactly. Yeah, I'm a full professor at the aerospace faculty of Delft University of Technology. And with my lab, I work on small drones, tiny drones, and how to make them fully autonomous. So these tiny autonomous drones can do many interesting tasks. And one of the main applications we're investigating now is how to have these small drones in greenhouses and how they can be useful there. And what are the challenges to make them fly around there and help monitor the crop.
Oh, really cool. Well, I'm curious to your talk. Looking forward to it. And before we go to watch the first talk, let's have a look who's joining. I can imagine Erik and Guido, you're both curious as well. A lot of people joining. I see Matt from Australia is saying hello. Eve Wilgenhof, Brussels. Hello from Zutphen, Frans Peter, and Laurie from China. Hi, Laurie. Great you're joining as well. Asse Delft, Jan is joining. Said from Istanbul. Well, I think I can fill the whole 45 minutes, so I won't, but welcome to everybody. Please use that same chat if you have questions during the talks of Erik and Guido, because after their talks, we've got 15 minutes Q&A time. So, we can hopefully answer all your questions. And for now, I would say enjoy and see you in 20 minutes.
Good afternoon, public, visitors. Welcome to my presentation. My name is Erik Pekkeriet, responsible for the robotics portfolio at Wageningen on agro-food robotics. So I would like to discuss with you today future robots in protected horticulture. So let's see what is happening there. So I think for growers it's not easy now these days. We have a very demanding consumer. The consumer would like to have a circular and resilient products, safe. They would like to see local produce, less logistics, less inputs, pesticide free, better precision and timing. On one hand, on the other hand, they would like to have it personalized. Everything should be tracked and traced, fast and reliable, delivered, customer driven, and also we see a rise of the fresh and soft fruit. So, and that's much more labor intensive. They also demand a perfect quality with long shelf life, so that they can reduce waste, and also that everything is safe and hygienically produced without contamination. So we see more and more the cold chain coming in also in the greenhouse facilities to produce and to pack at least as cold as possible. And on the other hand, you see also a trend that you would like to be as efficient as possible in the greenhouse to produce at a very high level. So you would like to reduce the add-on of energy, and also you would like to harvest energy. You would like to be year-round in control, also to deliver a year-round product. We see much more LEDs coming in. But as a result, we also see a temperature rise in summer, also due to the new growing, much more a humid way of growing will increase the product quality in summer if you can close the windows as long as possible. But as a result, it's very hot to work there. So for the worker conditions, it declines. And for that reason, I think it's really time to robotize the last bits and also bring robots into the greenhouse. And then we see another problem that also the worker is not there anymore. We see a huge decline of workers throughout the last century and also decade, especially also in continents like Asia and also Europe, where we initially had 20% labor force. It's now declined to 5% labor force, and also worldwide we see a huge decline. In Asia it's now still 20-25%, but also China expects that it will be 5% in 2042. So that's one aspect, and the labor is moving to urban societies. They can find much better jobs in the IT. The climate is much better. They don't have to work so hard, and there are jobs plenty. So that's our competition in the future. And on the other hand, we also see that already the workforce is aging. So also in China, in Japan, in Europe, the workforce who are doing now the easy tasks, the repetitive tasks, are much older than they were 10 years ago, and the younger people are moving to more IT-driven jobs. And in the open field, they are also very much aware of that, and they are also quite active to bring in there a lot of robotics. And I think in the greenhouse horticulture, we're even a little behind them. So they are now also automating their implements. They have their automated tractors. They do automated weeding, so also a lot of manipulation is already automated. And they have also very nice projects. One of the nice projects I found is also the hands-free hectare, where they just started with a demonstration project. This is the field where we would like to do a lot of different crops, and we would like to do it full autonomous. And I think these kind of projects would also boost robotics in greenhouse horticulture if we could start a few of them. And a very nice sector which is already far ahead is dairy milk production, dairy production, so dairy farming. There we see that farms are already robotized, and they can run 3 days a week without any human on the farm, and more than 100 cows will be milked, will be fed, will be cleaned automatically. So where are we? What are the technologies which are very promising, which really can help agriculture? I think we are quite ahead in 3D recognition with our camera systems. If we choose a multi-camera setup, for example, we can reconstruct the 3D models from out of the plant, and we can do that really fast. This is one of the examples where we do really fast 3D modeling of plants. We can count the leaves, measure the leaf surface, and we do this already in full 3D. And in the example in the right picture, you can see the different elements, and you can also see that we can sort these kind of plants with, well, 10 pieces a second. And if we have the 3D coordinates of the elements, we can also control robots to do also some manipulation. This is one example where I do genetic sampling of these plants, and we provide the coordinates and the path planning of the robot to do the cuttings. And based on that, we can do also other different cuttings like these. And next step is also use that for robotic harvesting. So you see more and more also in greenhouse horticulture robots coming into the greenhouse, but still standing at the front where the processing of things are done. So robots are not running into the greenhouse. We did a few attempts, for example, in this rose harvesting system on the right top. We harvested 90% of the roses, also at the speed humans do this, but yeah, unfortunately the company went bankrupt, and we ended up with no commercial application. And I think still we proved that the technology is there to do so. So what do we else have for technology? So we also looked very much into simulation. So when we look to the animation industry, they make very nice movies. And we thought, well, this is also a very nice start for us. So let's make also our plans in simulation, because if you buy a robot, you have your simulation package directly connected to it. But if you want to harvest in simulation, you do not have the plants. So we started to build these kind of plants. And if you have plants which really look real, then you are also able to do simulation. You can choose your camera positions, and you can even start harvesting in your computer. And that makes R&D very cheap and very fast. And you can do also other nice things with it, because if you have drawn these plants yourself, you know everything exactly. You know what sweet pepper is, what a stem is, what the wires are, and that makes it much easier also to automate that in the second phase, and also do the learning to the real world. So that's what we did. So what we did is, you have here on the left side, you have the artificial plants. We draw it ourselves. And on the right hand, you see a real picture. And they already looked quite like each other. But with some learning, we even made the real world look a little bit on the artificial world, and the other way around. The artificial world looked a little bit more on the real world. And then we start training. We start training the artificial world to the real world. And we did it in a few steps, and without doing any annotation or image analysis, but just using deep learning algorithms, we could transform from the artificial world to the real world. And also the objects could be found in the real world as well. So in this slide, you can see the sweet peppers, the leaves, the stems, the wires, the peduncles, and the nerves of a sweet pepper plant. And that's the power deep learning can bring at the moment. And you can immediately harvesting. And you can start searching, and with a few algorithms, you can see that we are able to find the sweet peppers quite fast. And this robot is controlled by the camera on top of the robot, so on the robot end effector, so to say. And this is a speed where also he found now just 5 sweet peppers, and this is a typical speed you could also do in practice. So that's what we did. we built a robot harvester for sweet peppers, and we were able to harvest in the same way. And most of this work was done in simulation. And when we entered the greenhouse, almost immediately the robot started harvesting. But still, we do not harvest 100%. It's still very difficult. What other options do we have? And it's still a very big step to go from full manual operating production in the greenhouse to full autonomous production. So are there interesting steps in between? And we think there are. So if we look to other robots, we can also use them to predict our harvest much better, and also to count them and to make also a yield map of every square meter, because there are big differences in our greenhouse. They look the same, but if you look carefully, and we are not aware of that now, but our camera systems are now, and they see big differences in your greenhouse, and you can control much better on your best producing spots in your greenhouse, so to say. You can also detect diseases, pests, you can check photosynthesis. So a lot of these camera systems are now these days able to look for much more. So we are very much in the strategy of first measuring yield and quality. I think this is commercially coming available soon. Then measuring stress with the photosynthesis measurements, and then run into disease detection. And these kind of sensor systems can run autonomously, can combine with other trolleys, and will come into the greenhouse quite fast, can run day and night. These are a few images where you can see how the robot is looking to stresses, to pests and diseases, but you can also use this camera to predict shelf life and for all different options. So what are the key messages I would like to provide? I think for robotics, the result of successful artificial intelligence and robotics is providing right feedback loops. So it's not thing you can do directly. I think that's the second point. Performance will come in good collaboration between robot manufacturer. He will provide the algorithms, but the learning should come at the location of the end user. So there is some interaction. He should provide the data sets, and he can. That's also very interesting, because the performance is done by the robot on one hand, but also what the end user provides to the robot on the other hand. And if you align that the best, you will be the best grower in the future. And you will have a technology head start that gives you good scaling opportunities, and you will know much more, because I think it will be a technology race at the end. And if you are a few years ahead, you will keep that head start towards your competitors. I think it's also important to search for the minimum viable product and then add functionality. I think robotics is there to do a 50% pre-harvest. Why not? And saving 50% of your labor force immediately. And I think it's also good to do some new business model thinking. How can you pay the R&D, because that is the big hurdle at the moment in greenhouse horticulture. We don't know, we don't have the investments in R&D, and the market is so big. So we need to replace 1 billion harvesters we still have. So if we believe the Chinese in 2042, we shall run to 5% labor force, then we really need to replace 1 billion farmer workers. So this is the broader, also the open field, but this is the challenge I see at the moment in agriculture in the broader sense. So this is my project. I hope you enjoyed it, and open for questions. Good afternoon.
Welcome to this presentation on drones in greenhouses. I am Guido de Croon, and I'm a professor at the Faculty of Aerospace Engineering of TU Delft. And today I will talk to you about the project that TU Delft, the Agtech Institute of TU Delft, does in collaboration with Royal Brinkmann, global specialists in horticulture. With this project, we will try to provide an important part of the puzzle to arrive at precision agriculture, in which the goal is to define decision support systems for whole farm management with the goal of optimizing returns on inputs while preserving resources. And specifically, we would like to go to a precision agriculture in which we will have information on a per plant level. In order to get there, we will need much more extensive and more real-time information. And we will also need much more extensive automation. Now, what role do drones play in this picture? Drones are actually great mobile information gathering devices. Drones are flexible, they can move in 3 dimensions, so they can go there where it is necessary to gather information. And this is what makes them so much more useful than fixed infrastructure. They can be used for multiple applications. They can monitor diseases and pests and see the effects of these diseases and pests on plants. And they can evaluate crop conditions, for example, to evaluate the growth and to see whether there is more water or minerals that are necessary for these plants. But when drones are flying in greenhouses completely by themselves to monitor the crop, they can also be used for additional tasks, such as climate monitoring or the inspection of greenhouse infrastructure. But of course, we will not have just a single drone flying around in a greenhouse. There will be multiple drones, and these drones will be providing lots of real-time data on the condition of the crop. This will result in big data. In the first instance, Royal Brinkmann experts can look at this data and evaluate it. They can, for example, tell the grower that there is a disease in their plants so that this can be detected very timely and can save a lot of money and plants. But of course, on the long term, this is not a sustainable model, because as the number of drones grows in the number of greenhouses that use them, this data will become huge, and it will be impossible to look at it with human experts. That is why we foresee that the experts will instill their knowledge onto the data. For example, they can indicate on pictures where they see damage caused by disease. And this will give big data with labels. And this is very valuable data, because such data can be used to teach an artificial intelligence to judge pictures in the same way as experts do and get comparative performance. This AI, the main advantage is that it can process huge amounts of data in real time. And then it is like having an expert looking real time into your greenhouse, which is unprecedented. But this is not the end of the story. The picture actually is even bigger than this. Because the knowledge of this AI can be used to control the drones. If the AI is uncertain about some plants, whether there is damage or not, it may send the drones there to take more pictures or to fly closer to these plants to get more high-resolution pictures. And it even goes further. After some time, we can give these drones a small version of this AI. It will perhaps not be that good as the big AI, but it will be good enough to determine whether some plants are suspicious, for example. And then the drone can take more images of these plants. And this makes the big data set even more valuable. Now in this picture we do not see humans at the moment, but it is our intention to keep humans into the picture. The Royal Brinkmann experts will still provide a very essential role in this process. They will be more coaches to the AI and looking at the most interesting parts of the data, the most uncertain cases, for example. And in this bigger picture, we will have an AI that will be more and more intelligent with a unique data set provided by these drones. Now, in our project, We focus on small, lightweight drones, and the reasons for this are as follows. Small, lightweight drones are very safe for people in the greenhouse, and this means that we do not need additional safety measures for the employees. Moreover, because they're so lightweight, there's very little downwash. They push very little air down, which is good for the plants. And finally, being small, they will be able to fly in narrow spaces. And this will be essential if we want to use these drones for plants such as tomato plants and fly between ranges of these tomato plants in the greenhouse. So one may wonder, if you work on very small drones, can they actually still be intelligent? Because it will be difficult to carry sensors and to carry processing. This is where the TU Delft comes in. TU Delft has an ample experience in making small autonomous drones. On the left you see a video of one of our flapping wing drones. This flapping wing drone only weighs 20 grams and it is able to fly completely by itself. It has a very small onboard stereo vision system that only weighs 4 grams but allows it to see distances and avoid them and avoid obstacles on the fly. And here we see the onboard images that are used in this process. On the right, we see a swarm of tiny drones that explores an unknown environment. This swarm, here consisting of 4 drones, is used here in a search and rescue scenario where they have to investigate an unknown place to find victims. They communicate together so that they can avoid each other, and they also avoid obstacles in the environment. These are the kinds of technologies that will help us to make swarms of autonomous drones in greenhouses. To end with, I would like to show you some first autonomous drone flight results. Here we see Sven Pfeiffer, one of the researchers on the project, start the drone and put the remote away. The drone takes off autonomously and then starts following a flight plan that tells it to fly over this range of plants up and down. We have modified the drone you see here in order to be able to navigate in this greenhouse completely by itself. After performing its flight, it will go back to its base station, where in a final application it will land in a box to recharge.
Heavy for a pocket. What can help encourage vertical farms to...
This video shows some of the onboard images. Here we see the takeoff and landing zone, and now we see the plants above which it flies. These quite high-resolution images provide a lot of information. Here we're looking at the video, but of course it is possible to also gather stills where it's easier to evaluate what is being seen. I thank you for your attention, and I will gladly take questions.
Yes, welcome back everybody. Welcome to the Q&A. Erik, Guido, thanks for the presentations. You might have seen it already in the chat, but there were a lot of questions. Erik, you almost couldn't hold it. I said stop, because we need to save some for here. Eh? But afterwards you can all answer all questions that are not answered yet. I would like to start with a question of Alexandra Laskowska. There was already a short discussion in the chat because she firstly asked to you, Erik, automation is pretty heavy for a pocket. What can help encourage vertical farmers to automate the indoor farms? And then Franz Peter, thank you Franz Peter, he answered already. Vertical farming, the key to automation success is standardization of technology. And then her second question was, is there many standard solutions now already existing? So I thought, let's put this on your plate. Can you say something about this?
Yeah. Is robotics so expensive? I don't think it is very expensive. I think the R&D is very expensive, and we are reinventing the wheel a lot, especially in vertical farming. So you would like to see standards, but first come with at least one good solution, which is full automated, and then downsize technology, and perhaps you can make your own standard. But at the moment, I do not see very full autonomous solutions, which are also very cheap. And I think that is more an R&D question. So we don't have the money to do the R&D right, and we would like to start immediately with vertical farming and show that we can grow within a few months, and that is possible from a technical, but then you will pay. Yeah? And I think that's also lacking in the whole robotics, that there's a shift. We are very much SME organized in the greenhouse horticulture, small and medium enterprises, and we are not used in doing the good R&D. So when we have an idea, we build it, and then we come to the conclusion that it is not so easy and it is too expensive. But I think the sweet pepper is a nice example. If you look to the sweet pepper, it stands on the exact same location where a human is standing. So assume that he can do it in the same speed, but he can also do it 4 times as slow and still have a viable business case, because he is cheaper. He can do it 24/7. He has a payback time of 3 to 5 years. So then it will really come to you, but you really need to do the R&D, and we are lacking the business models to pay the R&D.
Yeah, so that's also for vertical farming the case. Good R&D is necessary to make the business case.
I don't believe it's expensive, and I think the sweet pepper, if you look carefully to the sweet pepper, it's only an industrial manipulator, and the robot, it's the hand, because in the hand you will see the illumination, it's the only camera, it's the gripping, it's the knife who cuts the fruit, and that's the whole robot, and in materials it's not even €1,000.
Wow, yeah. And how's that for drones, Guido? Is there a good business case to make for drones?
Yeah, I definitely think there is a good business case to make for drones in greenhouses. And so the first things we're focusing on is the detection of anomalies like diseases or pests, where typically you have to clear out. Yeah, typically this is detected quite late because it's difficult to access or to keep an eye on, and that's the thing that these drones solve. And also like Erik said, you have to think about the minimum viable product. So with robotics, interacting physically with objects is quite a challenge, and even there's quite some progress. And the thing with drones is that in the first instance, we think of them as mobile sensors. So they can basically stay clear and do not need to interact yet with the plants or the crop. And they can just fly and observe. And there's also challenges, though, in terms of they have to do this completely by themselves. And also there's gradations of difficulty from flying over low growing crop to flying in between tomato plants and stuff like that.
Yeah, about the tomato plant, you already mentioned it briefly. It is suitable for tomato plants, but maybe you can tell a bit more about it, because Guido van Stekelenburg asked the question, are drones also suitable for example, tomato greenhouses, as there are a lot of obstacles for those drones, like the wires where the plants are growing around, etc. Can you tell a bit more about that?
Yeah, so well, first challenge that we're focusing on is localization and how they can fly in a part of the greenhouse and come back. And then the next challenge is indeed obstacle detection and avoidance. And that is why indeed these tomato plants greenhouses are more challenging. So one of the challenges that you have on drones is that in principle, you want the drone to be as lightweight as possible in order to be as safe as possible. In the same time, the lighter you make it, the less sensors you can carry on board and the less computing power. And this while solutions that are made for self-driving cars are typically pretty heavy in terms of sensors, in terms of processing. So this is a challenge that we have been working on at TU Delft for a long time. So there are solutions. Now, the other Guido mentions wires. That is one of the most challenging parts indeed. Because those are very fine structures, and there also resolution of the camera will start to really become of influence. But I mean, it is possible to be able to perceive them, or to say, okay, this is something you want to avoid, is that you would need to adapt these lines to be better visible. But that is going to be one of the bigger challenges indeed.
Yeah, and you're working on it now.
Exactly. So, I mean, tomato plants and stuff, that is definitely going to work. And then, the finer the structures become, the more challenging. And that is why there's also still a need for research actually in this area.
Yeah, which are the most challenging crops for this?
As said, like the tomato ranges where you would like to have them fly in between, taking pictures of tomatoes, etc.
That's the most challenging crop of all.
Yeah, I think so. Yeah, what I have seen in greenhouses, but I'm not a greenhouse expert, so perhaps if somebody else can suggest an even more difficult crop, then I would be interested.
Maybe Erik knows.
No, it's also changing a little bit. Also due to the vegetative, to the LED lights, you have a much more vegetative growth of the crops. So the corridors are also getting smaller where the drone can fly into. So it's really challenging. Yeah. And even leaves are even touching each other. So it will be difficult in the future.
Yeah, exactly. Erik, another question for you. What would you add to horticulture branch to accelerate the innovation rate? In words, what are key success factors missing yet? Question from Frans Peter.
Yeah. What I really miss is R&D power. So people, and I think we did now a good example with the plant life. So there are a few good examples where we have the time to really make something which works quite well. So R&D power comes also with R&D money, and that needs to be organized in a different way. And on the other hand, I also really much, and I also would like to point out what Guido said, is that searching for the minimum viable product. So it's also an evolution. It's not only a disruption. I also think it's a disruption, but on the other hand, also think about the evolution where you can also just start. And I really would encourage a project to be the full autonomous greenhouse, for example, but then also not only from the climate point of view and the growing point of view, but also from the handling point of view. And I think start remotely. So, but then try and teach try and teach the robot so that in the end it can do it himself. So that would be perfect. These kind of disruptive projects would be perfect. And now we are a little bit waiting. We are trying a little bit. We see a startup, waiting for the startup, and I would encourage much more R&D power.
Yeah, thanks. Guido, back to you. Felix Akens is asking, how do you deal with abiotic stress induced by the drones, especially with a lot of drones flying low above the crop very regularly? It seems potentially problematic.
Okay, so Erik, abiotic stress. You must know what it means.
Guido, just fly higher and use small drones, and you will not run into problems.
And there's no abiotic stress.
There's no abiotic stress.
The thing is, it has to do with the downwash, I guess, with the aerodynamic pressure put by the drone on it. So that's exactly one of the reasons why we're really focusing on very small drones. So the one you see flying here above me, it's big like this. So it weighs 30 grams.
Oh, really?
It also means that it pushes down 30 grams of air. Now, the solution for the greenhouse is going to be slightly heavier because it has to be much more intelligent even. But we are working really on the lightest solution we can find, which means that also the downwash is much, much less on the plants. And so it's already very little to begin with. And then indeed there's the flying height, where there's a trade-off, of course, between flying a bit higher, which reduces further the downwash, so this aerodynamic pressure, and of course having the right resolution to see what you want to see with these devices. Can you still recognize, for example, the damage done by pests if you fly at a certain height? So I hope that kind of answers the question, but it's one of the main reasons why we're also focusing on these small drones.
Yeah, but we could also change the lens, Guido.
Yeah, exactly. So you can play with all kinds of exactly parameters. You can change the lens to have a smaller field of view, but a higher resolution. So there's many parameters to play with and to investigate. Yeah.
And Guido, when do you use drones and when ground UAVs?
So when would you use ground robots? So the reason that we're working on drones here is the flexibility also of 3D motion. And so they move pretty quickly. They can move pretty quickly through the greenhouse. Actually, my lab also does drone racing even, so I can tell you they can fly very, very quickly. And so, of course, it depends on what the drone needs to do. So if you want to scan all the plants, then you probably want to fly not too fast in order to get nice images of all of them. Yeah. But suppose you need to return somewhere, you can do this really quickly. And so being fast is one thing. Moving in 3D is another one because crop may grow. You may have high growing crop where you want to fly not only between ranges, but perhaps you also want to fly over the ranges. And so it's really the flexibility, and the fact that if you have chosen a lens on board, then you still have the flexibility to make higher resolution images by just going closer to the plants. And so, these are some of the reasons why drones are a good idea. Of course, I think ground robots are a better idea if you want to manipulate the plants. So if you want to do harvesting, stuff like that, I don't see that happening with small drones anywhere in the near future.
Yes, and it's also difficult to carry artificial light on a drone. That will also be heavy. So that's also a disadvantage on drones, but I think it's very flexible, as Guido said. And if it works very well, and I think technology is progressing in that direction, then drones are, you can start them behind your desk and they will get the information and bring it back to you. So that will be a great advantage of drones instead of heavy trolleys. On the other hand, you still need, we are at the moment focusing in our group a little bit more on the trolleys because we are focusing a little bit more on what they should do. So they should at least determine the quality and yield very precise, and you need a lot of images. And then at the moment, the drones are not that precise and not robust enough. So that's why we still keep grabbing to these vehicles, and we can carry artificial light, which is also very important if you would like to use all spectral bands in a very precise way. Then you also need, and you do not want to have shades. That's also an issue when the sun is shining. You have a construction on top of you and it will generate a lot of shades. And in some cases, you cannot measure precise enough.
Thanks. I have a look at the time and I already see that we're actually already out of time. But before we go, I have one last question for both of you. The same question. So, and I would like to end with that question. And the question is, what needs to happen to make the horticulture industry completely autonomous? Erik, I start with you.
Yeah, I give some clues already. I think
Yeah.
it's
R&D.
R&D investments and yeah, probably also other business models where perhaps also new industrials are coming in, or that the existing industrials are organizing themselves in another way, because these kind of technologies will come with big investment, but the payoff is wonderful in my view, because you can copy it easily. If you need to harvest, you probably need four robots per hectare. An average greenhouse in the Netherlands is 10 hectares, so you need 40 of exactly the same robots, and then it will definitely come towards you. You can do it 24/7. Yeah. So that's my wish, and be a little bit more disruptive. Just start a greenhouse, fully autonomous. Let's see what happens.
And invest in R&D.
Yeah, exactly.
Yeah, Guido, some last words for you?
Yeah, I think that Erik has important points, because there's two things that need to happen if this is going to be a reality. And one is that we need to close the gap between what is possible in research and academic research and what is necessary for an actual greenhouse. And closing that gap is difficult, is going to need funding. The second thing is that what I think horticulture also needs is that research is steered into the right directions that are necessary for their application, because personally, I've been working on this for some years now. And I mean, the greenhouse environment is very challenging, but if you want serious research to be performed on this, then that also needs the funding. In the same time, I think there's big technological challenges also ahead. For the drones, the main challenge is how to make them completely autonomous and robust. I think I have more trust in their robustness than Erik, but so to make them work in an ecosystem where I think that there's place for different kinds of robots actually in the same time, and where each has their strengths. So and I hope and if you really put this together with like big data, AI, I think it's gonna be a huge thing for the horticulture sector. So I hope it's going to happen.
Yeah, I'm really excited about the developments coming years. So let's see if next year at GreenTech we are a bit further in this. Well, Erik, Guido, thank you so much for being here, for giving the presentation, but also being here live at the Q&A and answering these questions. If you have time, please go to the chat to maybe answer some more, because I think there are a lot of questions left. Unfortunately, we couldn't answer them all. For the people who are watching, thank you so much for joining us. This second day at GreenTech Live and online came to an end already, but tomorrow there's an interesting program, a full day, so definitely come back tomorrow. And for now, I hope you have a really good evening, or for some day, because it's in our different times, of course. So enjoy your day or evening, and see you later. Bye-bye. Thank you, Guido and Erik. Bye.
Yeah. Bye-bye.
You're welcome. Bye-bye.